Hello everyone, it's June the 7th. A little bit late today. Had a lot of meeting today, so kind of delayed doing this. Also, I need to finish like some homework. But anyway, here we are. It's a new week. We didn't have a difficult one yesterday, which is suspicious. So I'm not sure what we're gonna have today. They just gonna move the difficult one today. Hopefully not. Not in quite a mood for a difficult one. Alright, let's take a look. Minimum cost climbing stairs. It's got to be a medium question, and seems like something I've done before. Give an integer array of cost. Cost I is the ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. Climb up. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top of the floor. Cheapest to start on 1. Pay that cost and go to the top. So the top is here. Cheapest to start from 0 and only step on 1s. So we pay 1 and then go 2. And then we pay 1 and then go 2. We pay 1 to go 2, and we pay 1 to go 2. Alright, so skip 0, 1, 2, 3. Skip cost. So we pay 1, 2, 3, 4, 5. Hold on. We pay 1, we go here. We pay 1 again. Go here. That's 2. We pay 1. That's 3. Okay, 1. That's 4. Okay, 1. That's 5. How is 6? To reach the top of the floor, it says here we start on cost 1. But if we start on index 1, we start here and then say we pay that cost and go to the top, right? Oh, the top. I think this is not the top. This is the top. So we have to go boom, boom, go to the top. 2 steps, go to the top. So top has to be larger than this. Yeah, now it's 1, 2, 3, 4, 5, 6. Bless you. Go to the top. We're skipping 0, 1, 2, 3, skipping this one. Bless you. Okay, so cost length is 2 to 1,000. Okay, so most likely it's a DP, right? So this type of question usually is DP. So again, we go with the simplest case. If we have only 1, right, then we take 1. There's no question about it. If I have 2, right? If I have 2, the idea is if I know the minimum steps. So what is the minimum steps? So the minimum steps is either including me or it does not include me, right? That's the thing. Either include me or it does not include me. If the minimum step is going to include me, then that means the previous step is either the one right in front of me, right before me, or the one 2 steps away. Right? There are only 2 ways to connect. So I just want to know the minimum cost to reach the step right in front of me, and the minimum cost to reach the step 2 steps away from me. And then we choose the minimum of the 2, right? Then that's the minimum steps that can allow me to take my current step. So then I have a choice, right? I can take the current step, right? Or I can also not take the current step. So I have to take the current step. What's the cost of taking the current step? If I don't take the current step, which is fine because I don't have to take, so like at each step it's either, so I compute the minimum cost, that is to okay, what do I, the minimum cost of taking the current step, right? So I have, if I compute the minimum cost to take each step, then to reach the top, right? To reach the top, that will be, so the top is the one after. To reach the top, it can, so it's going to be the minimum of this, taking this step or taking this step. All right. So in this case, the minimum of taking this one is 10, right? There's no other way. The minimum of taking this is either the one before, which is a 0, or 10. So this one becomes 15. The minimum of taking this one is going to be either 10 plus 20, either 10 or 15. So it would be 10 plus 20 would be 30, right? Taking this step, minimum cost is 30. And here, it's either 30 or 15, so we pick 15. Okay, that's good. Let's do this one. Write it out. We're going to write out a DP table, right, which has the first value is 0, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the first one, this one is going to be, the minimum is 1. Like there's no other way I can go, right? It's 1. Now 100, to take 100, I just take 100 by itself. To take this one, last year, to take this one, it's either take 100 or 1, so I take 1, so it's been 2. To take this one, it's going to be 3. To take this one, it's going to be 3. To take this 100, it's going to be 103. Take this one, it's going to be 4. Take this one, it's going to be 5. Take 100, it's going to be 104. And to take this one, is going to be 6. So for the last one, we're going to compare 6 and 104. So we take 6. Yes, that's a DP. Now, that is an ON DP. I think it is possible to make it into an O1 space complexity DP because we are not using, like once we pass certain values, we don't use anything ahead of us, which means we can just have a current, right? Pre-current, and then we loop through. So pre is going to be 0, current is going to be the first value as 1, and when the loop starting from 100, so it's 100, and then we can say current going to be 100 plus the minimum of pre. So current is going to be 100, and the pre equals, we'll have to use temp. Hold on, we can probably swap. So pre current equals, so current is going to be 100 plus minimum of pre and current. That's current pre equals this, and the pre is going to equal to current. Okay, let's code it up. Let's code it up. So I'm gonna copy this and st this. Alrighty, let's take a look. I hope that is correct. Man, based on my current analysis, it is correct, and it's also very elegant. You know, every time when the solution feels elegant, most likely it's going to be correct. That's what LeetCode is. They like elegant solutions, right? So we're going to say pre-current equals 0 and cost 0. I'm going to say for C in cost 1, right? And then we say current pre equals current plus minimum, current and pre equals current. And then we're going to return the minimum of current and pre. And then test case. I only have 2 test cases, but I think it should be sufficient. First one is 10, 15, and 20. And we'll go with 15. Second one is going to be 1, 100, 1, 1, 1, 100, 1, 1, 100, 1. Give us 6. And here is cost. Here is minimum, cost. Try it. Both pass. I think that shall be it. Let's test some like this. Like this is edge case because edge case is 2. Yeah, I think that's correct. All right, let's take a look. Pending. Accepted. Nice. So this is basic DP, right? This is a very basic DP. At each step, right? At each step, we compute the minimum overall cost of taking the current step. And there are 2 ways to take the current step. One way is to take the step immediately before, and the other is to take the step two steps back. To compute the min cost of the current step, we take the min cost of taking the 2 possible previous steps. By doing this, we can create a DP table that lists the min cost of taking all steps. The solution, the answer, is the min of the last 2 steps. And of course, we can simplify the space complexity by using only pre and current to point to the minimum cost of the step right before and the step 2 steps before. So runtime is ON, and this one shall be pretty fast. Yep, 60 milliseconds, right? And we arrive at 47% ranking. Yeah, I don't think there's too much to say about this. Yeah, the DP, the ideal is just we try to find. Actually, I think the idea is going from the back to the front, right? So we want to find the minimum cost to reach this position, right? And to reach this position, the only way we can go is go from here to here, or go from here to here. So what we need to know is the minimum steps, the minimum cost of taking this step, and the minimum cost of taking this step. And then this is just a repeating question because this is no different from this. So to know the minimum of taking this, we need to know the minimum of taking this and this. To know the minimum of taking this, we need to know the minimum of taking this and this. So we go all the way down, all the way back to the front, and then we have the DP DP relations. Yeah, this is I mean, this type of question will be difficult if this is the first one you do it. Oh, it's an easy one. I thought it's a medium. Of course, it's easy. Yeah, it's an easy question. Agree, it's an easy question. It's a very, I mean, I'm pretty sure if this question shows up at the start, at the very beginning of LeetCode, it's going to be a medium question. But if people have been doing it all the way to 746, right, and people shall be able to understand the DP behind this. Pretty straightforward. Tabulation. Yes, this is a tabulation. I think it's that's the code. Tabulation is 2-step, 1-step, 2-step. Yep. A minimum cost. That's good. Recursion and memorization. You can do recursion for sure. They don't have to. And they probably also have a constant space. Yes. Constant space. I think it's the same. Range 2. Range 2 to land cost. Temp. The minimum of this. Return. That's fine. New to dynamic program. Okay. It's about practice. It's all about practice. You know, you have enough practice, it starts to feel more comfortable of thinking this way. First hit. Yeah, I think when you get it, the first hit is just a reversed cost. Yeah, I think it's just people practice more. This type of questions, you practice more. And yes, doesn't this look like Fibonacci, right? It's just instead of plus, we take the minimum. Yeah. Cost I plus, yeah. Good. I mean, that's it. It's a lot of people have a lot to say. 4 ways. Doubt. If you pay 10, climb 2 steps to reach 20. Final steps ahead. Good drawing. Good drawing. All right. The art of dynamic programming. All possibilities are considered via brute force, top-down, depth-first search. Remember, each subproblem's optimal solution via a DP memo. Turn a top-down solution upside down to create a bottom-up solution, bottom-up memorization. Instead of starting the entire, we only use 2 values. Okay, base case. Is this JavaScript? No. Fun. What is this? Fun. I don't know what this language is. Yeah, this is JavaScript. Kotlin. That's right here. Kotlin. Base case. Reach the top floor. N smaller equal to I. Recursive case. Hold on, this is your recursion. The base case is here. You move base case down. That's the base case. When you reach the end. Otherwise, for I, right? For the cost of step I is the cost of the next step, minimum of the next step, and 2 steps ahead. Yes. Each subproblem, optimal solution via DP memo, which means we can memorize, right? Memorize the MI, yeah, we memorize, and then we swapped to go bottom up, and then we bottom up with save the space. Oh wow. Cache. C++. Oh my god, how many solutions did you write? How should I say it? I mean, this is a typical DP, right? So I like to start thinking, I mean, it's different. Sometimes I think top down, especially if the recursion relation is very intuitive. I remember a few days ago we had a problem. I had just so much trouble thinking about bottom up. Actually, I forgot how to do the bottom up. I think I still remember how to do the top down, but the bottom up, yeah, I forgot how to do the bottom up. But the bottom up sometimes is, for me, it's hard to think. Top down is always easier to think, but this type I've practiced before, so bottom up is easier to come by. I probably need to go back to the problem a few days ago, like how the bottom up work. I forgot. All right. Anyway, so that's it. That's it for today. It did pretty well. I mean, it's an easy question anyway. So, all right. See you guys tomorrow. Adios.